Hey everybody, thank you for taking a look at that four corners activity. I think a lot of you are on the right track for a lot of the problems, but I thought it would be helpful to do another verbal walkthrough so I can show you my work. I'm going to start in the lower right hand corner with a conceptual visual problem. So the original function was g of x equals e to the kx plus f of x. The first derivative would be up here, k times e to the kx. The k is the derivative of the exponent, so there you're using the chain rule essentially. Add to that f prime of x. Now they told us to find g of 0, or g prime of 0 rather, so I went ahead and I plugged in a 0 everywhere there was an x. Well, f prime of 0 they told us was 3, and then I plugged in a 0 here, which would lead to e to the 0 power, which is equal to 1. So this whole term becomes just k times 1, or k. So that's the expression that's going to give me g prime of 0. It kind of sounded like maybe they wanted you just to come up with a number, but remember we're looking for g prime and g double prime of 0 in terms of k. We don't know what k is, that's just our constant kind of hanging out right now. The second derivative, again, use that chain rule. Find the derivative of the power, which would just be k because it's k to the x. X is first degree. Constant k times the original part from the g prime, and then the double prime of f. So then when we evaluated at 0, I turned k times k into k squared. I plugged a 0 in everywhere there was an x. So e again to the 0, e to the 0 is just 1, making the first term k squared. And then f double prime of 0 in the given information was negative 1. So I can rewrite that g double prime of 0 is equal to k squared minus 1. So I know in the past when we've evaluated it at a given point, we usually come up with just a number answer. In this term, we were looking for an answer in terms of k. All right, then in the lower left-hand column, or corner rather, I gave you two graphs. So f of x was drawn in purple. It was this piecewise defined linear function. And then g of x is going to be in red here, this quadratic equation. So what we want to do is find h prime of 2 if h of x is the composite of f of g of x. So I have just the wrong notation here. This was my original given function. This h prime should be right here. H prime is f prime of g of x times the derivative of the inside stuff, which would be g prime of x. So then this is kind of where it gets fun but hard, confusing but easy. So first of all, g of 2, remember that g of x is red, g of 2 is going to be 3. So go to 2 and find the function output, it would be 3. Then f prime of 3, so what I'm looking for f prime of 3 is what's the slope of this f function, which is linear, at the point 3. Well, here's the point, but what's the slope of that line, or what would the slope be there? I'm thinking rise over run. Change in y is 3, change in x is 1. So the slope of that line is also 3. Okay, but g prime of 2, so at g prime of 2, here's the function, and prime means what's the slope, what's the rate of change at 2. Well, we know that at the top here we'd have a horizontal tangent. Horizontal tangent's slope is 0. So 0 times f prime of 3, which we did find to be 3, but it's going to be equal to 0. You know, really, had I kind of considered this part first, this would have all been unnecessary, because 0 times anything is 0. So the correct answer for that one was 0, and lots of you had that right. All right, now I'm going to move up to the upper right-hand corner, the numerical problem where I gave you a table of values. So I think the majority of you got this one right. I was looking for h prime of 2 if h of x is the composite g of f of x. So using the rule for a composition function, chain rule is what they call it, g prime of f of x times the derivative of the inside stuff, which is f prime of x, derivative of f of x. So then plug in your 2. I'm going to find g prime of f of 2 and then multiply it by f prime of 2. F prime of 2 I found from the table. F prime of 2 is negative 3. And then f of 2 I also found from the table. F of 2 is 0. So here's my 0. And then g prime of 0 is 5. So 5 times negative 3 is negative 15. If you got something else, take a look at what you did. I'm not sure. Some of you had negative 18. 2 out of the 5 of you, I think, had negative 18. Reconsider that one. All right, now the first problem, the analytical problem, this was a doozy. And I came up with this. And you all, I think all 6 of you, all 5 of you, maybe 4 of you, I don't remember. Most of you came up with the answer. I've got to click out of this. Most of you came up with the second derivative would be equal to -2 times cosine x over 6y. And I know exactly where you got that answer. You separated the variables and then you took second derivatives on both sides. And you made me stop and think, like, oh, could I maybe have done that myself? Your answer was so much more simple than mine. My answer was so much more complicated than yours. So maybe we're both right. Well, you know what never lies? The graph. So I went to Desmos, I typed in your answer, and your answer is all these red ovals or ellipses. And then I typed in my answer, and my answer is here in blue. And then I double checked and triple checked to make sure that I had typed my answer incorrect, I had typed my answer in to the computer program correctly, and I had. We do not have the same looking graph, so I guess one of us is right and one of us is wrong. So I'm going to say that I'm right because I have the textbook with the answer in the back. And the correct answer is this garbage. All right, so let's talk about this. Here's the function. Find the first derivative in terms of x and y. So the derivative of y cubed would be 3y squared. I took the derivative of y with respect to x, so I have to include this notation. And then I took the derivative of y, which would just be 1. But I took that in terms of x, so I have to include that notation again. Factor it out, you're left with 3y squared plus 1. Now, over here, when I took the derivative on the right-hand side of 2 cosine x, that's 2 times the derivative of cosine x, which is negative sine x. I chose to rewrite it like this. Da-da-da-da-da-da-da. All right, now I'm ready to do the second derivative. I totally understand what you guys did. You took the derivative of, you swung this dx up here, and then you took a second derivative here, and you took a second derivative of there, and then you, just kind of like swung your dx back down. Unfortunately, I guess that's not the way it works. I wish I had a better explanation other than when you're taking the derivative here just in terms of y and over here just in terms of x, you're not really differentiating like this side in terms of x when you do it that way, that's called separation of variables. What you guys did was separation of variables. No dice there. So you have to then set dy over dx equal to something. And now you're going to do implicit differentiation. So implicit differentiation is where you implicitly take a derivative with respect to x. So I use the quotient rule to derive again. And here's my du from this u. Here's my dy this should be dv, my bad, from v. So pretend that says dv. And then here's the quotient rule, v du minus u dv, pretend that says dv. And notice how my dv still contains this dy dx expression because I didn't derive this in terms of y. I'm still trying to derive it in terms of x. All right, so hang on to that. Now, also in this step right here, just because I am using my best algebra skills, I said to myself, I'm going to break this up into 2 fractions right now. I mean, I'm technically dividing the whole thing by v squared. But just for my own algebra ease, I thought I'm going to break it up. Okay, so I broke it up, and then I was able to cancel out one of the 3y squared plus 1s in the first rational expression, so in this first part. Over here then, I simplified the numerator to become 12y times the sine of x, and then the 2 negatives would cancel out, blah, blah, blah. See what I've got going on there? I guess I can't scroll down. And then now dy dx, I have to include that. What is dy dx? So you know what dy dx is in terms of x and y. So plug that in, and then you can leave your answer just like I've got it written and boxed up right here. On the AP exam, there's no need to simplify. No need to simplify. I like what Mark said yesterday or today about if you can plug it into a 4-function calculator, then leave it alone. And this is something I could totally plug into a 4-function calculator. All right, but when I worked the problem the first time, I did kind of simplify a little bit further. I wrote it all over one common denominator. The common denominator would be 3y squared plus 1. That quantity to the 3rd power, because I've got 3 of those over here in the second rational expression. All right, so if you want to maybe rewind and listen to that excuse me, explanation one more time, go ahead. Otherwise, get on with your life. Thanks, guys.